Yan. Okay. So here I have included on the forefront or upfront of our assignment tab the instructions. Okay. So it's a group activity. Yes. Okay. So nasa inyo na yun, how will you gonna make it something that is similar or common for everybody within the group? Now, what are the things that you're gonna be needing? You're gonna be needing fresh pineapple, okay? Then, canned pineapple, papasko na yung mga pineapple chunks ni mama, pineapple juice, and then gelatin powder. Okay? Then isang pineapple powder juice. Okay, so we're actually gonna test the strength of the enzyme capacity of all samples of pineapple that we have available that can be obtained at home. Okay, so you will be needing four transparent cups. Kahit yung baso ng magtataho would do fine. Now, so syempre, ma'am, magkakaiba po kayo ng bahay. Meron ba kayong time na mag-meet sa inyong class before mag-Wednesday o ako lang yung nagka-face to face sa inyo? Siguro may face to face naman kayo, 'di ba? Ako lang ako lang? Hala, sige. So kung ganito, ang gawin ninyo po is, since hindi kayo magpupunta ngayong Wednesday, pahinga tayo muna. Pahinga muna ako. Kasi ano eh, ano 'to eh, yung ubo ko 'to tsaka ano pagoda ang lola ninyo eh. So, tumatanda na tayo, we're not getting any younger. So, ang mangyayari diyan is siguro bibili kayo ng tig sa ₱10 na taho. Okay, taho sa umaga. Then, kunin niyo yung plastic cup na yon. Okay? So, four cups per group. Ay, hindi, bali five na. Five. Okay? So, marami naman kayo sa grupo. So, bahala kayo. Now, ang mangyayari dyan, since this is a group effort, you're all gonna be preparing four cups with four pwedeng flavored or unflavored, whichever is best for you. Then, ititimpla nyo yon at ipatitigasin nyo yun dun sa apat na cups. So, i-assign ninyo bawat kaklase ninyo na mag-experiment sa bawat cup. Okay? Na hindi naman kailangan pong punong-puno yung gelatin. Siguro kung ganito kataas yung cup ng nimang taho, siguro kung kalahati, so pag-usapan ninyo. Kaya I don't have with me a taho cup na tinitinda na taho cup. Huwag yung ₱5 naman guys. Yung ₱5 parang maliit na ice cream na yun na yung dirty ice cream. Hindi, yung mga pang ₱10 lang. Siguro kalahati nun. So, bahala kayong mag-usap nun. Then, you're going to assign your group mates one variant of pineapple. So, isa si pineapple na fresh, tapos na-chunks ninyo, i-cut ninyo na maliliit. Okay? Yung isa naman, yung nasa can. So, yung medyo siyamanin sa can. Yung isa naman po, pineapple juice, unsweetened. Sabi niyo, ma'am, pwede ba yung Del Monte sweetened? Hindi po. Unsweetened. The sweetness will have an impact on the, we have an impact on the quality. Okay? So, unsweetened tayo. Okay? And then, yung isa naman is powdered pineapple juice. Okay? So, gagawa ka ng pineapple juice na concentrated, konting-tunting tubig lang, tas yun yung ihahalo mo. Now, mag-agree kayo kung gaano kataas yung idadagdag nyo na pineapple. Now, make sure na yung idadagdag nyo, dapat yung covered, yung paligid, yung mismong ibabaw ng pineapple. Okay? Kung kailangan yung tadtarin, or ikat ng mas maliliit, yung pineapple, that's well and good then. Okay? So, yun po. So, kailangan covered po yung ibabaw nung um, inyong baso. Now, I'm thinking baso kasi ito yung something that everybody will be able to get a hold of. Kasi nga hindi tayo mag-meet sa Wednesday. Okay? So, yan. That's why I included knife, napkins, para maglinis naman kayo pagkatapos yung gamitin, ha? Wala tayong katulong sa bahay. Okay? Spoon, water, and ruler. Now, you need the ruler to measure it. Okay? So, I included the procedure here. So, you're going to be mixed preparing the gelatin, kaya nga gagawin niyo siya sa bahay ninyo sa Wednesday pa lang. Okay, para hindi kayo, you'll have plenty of time to do that at home. It's gonna be one whole day evaluation or monitoring. So yeah, so I included here the procedure as mentioned, and then for equal amount. So yun, since hindi niyo ito magagawa ng isang bagsakan lang, kanya-kanyang gawa sa bahay, pag-usapan ninyo kung gaano kataas. Siguro mga, kung ganito kataas yung baso, 2 to 3, gawin yung 3 inches siguro yung height ng, check nyo muna baka kung 4, mag-adjust na lang kayo pero kailangan pare-pareho yung height ng gelatin ninyo from the bottom to the height to the upper portion of your gelatin. Okay? Then add your small chunks. So i-assign niyo yung isa sa inyo, so isa sa cup A, isa sa cup B, cup C, tapos gelatin plain. Yung isa lagay ninyo, yung isa pa is powdered juice. Okay, canned pineapple at saka powdered juice. So dagdagan natin 'to. Okay? Then observe it, uh, measure the height right away. So that's preliminary niyo, then maglagay na kayo. And then afterwards, you're gonna be measuring it with the intervals of 30 minutes, 1 hour, 3 hours, 9 hours, in 1 day. Okay? So, yan. If you want to take pictures, that's fine with me. Pero alam niyo naman, it's gonna be submitted individually. So, you consolidate your pictures. Nakita ko yung mga ibang mga sagot ninyo, guys. And I see that it's a common answer. Hindi katulad dati na kanya-kanyang laboratory manual. Okay? So, this is what the report is gonna look like. Yan. Okay, so this is what's the report. Okay, so yeah, of course, do not forget to fill up these details. And it's still the same, guys. From day one, I already mentioned the format that you're gonna submit it with your last name, first name, and the name of the file that you're going to submit. Wag mong kakalimutan yon. So, it's gonna be for this time, it's gonna be your last name underscore your first name, experiment 10. Okay, .pdf. It's only PDF. So, dito po, ang ilalagay nyo dito is the amount of liquefied layer. Okay, so magli-liquefy siya. So, ma-measure nyo na ngayon yon. And then, as the time progresses, you're going to be comparing it as well. Okay? So, yan, mag-measure siya for yung pagkagawa ninyo. So, definitely yung height. So, dito yung height niya. Okay? Then, for after 30 minutes, what's the height right now of your gelatin? Okay? Siguro sabihin ninyo para gusto niyo mas klaro or mas defined yung explanation niyo, yung height ng gelatin from, let's say, naging 2.7 inch na lang siya. Then, 0.3 yung water level, something like that. Okay? So, include also the height of the gelatin and any liquefaction that has been produced in the process. So, you do that with a timestamp that is requested here. And then, within 24 hours, what's the status of your gelatin? Okay? So, yan po. Now, so, hindi na po dito, so, dapat walang ano can we add, sige, edit ko na lang to, wait lang. Edit natin to para dagdagan natin yung cup E. I forgot the cup E. Para maisama yung inyong, ano, yung plain gelatin lang. Okay, so swerte ko sino mapupunta sa plain gelatin. So, pag iparaffle nyo yan na kasi sayang naman. Wait lang. Yan, cup B. Wait lang, i-update ko lang yung mismong file para kasama yung ano, update na lang natin pati yung description para hindi na kayo mahirapan. Cup A, pineapple fresh pineapple. Cup B would be uh, canned pineapple. Then cup C, um, canned juice. Wait lang guys ha. Hindi nakikita yung ano ko kasi nakaano lang yung. And then, powdered, uh, prepared. Okay, wait lang guys ha. Okay, modify ko lang to guys ha. Sorry, wait lang. Okay, wait lang po ha. Upload. Ayan. Pasensya na sa spelling ng file. Yan. Okay. Let me save this. So you have 1 week to work on this naman from Wednesday. From today. So ito na po yung updated na file. Yan. Okay. So this is what's the new file is gonna look like. So yan, para at least identify ninyo what are the things that you're gonna work on. So if in case you're gonna be assigned for group cup A, you're gonna be working with gelatin and fresh pineapple. Okay? So yan. So cup B, cup C. So ito yung mga Del Monte na nasa lata na po And then cup D, prepared powder juice. So yung mga tang or whatever na basta pineapple juice na prepare ninyo. Okay, and then cup E will be gelatin. Although gelatin lang siya, it will still be measuring the height and any liquid that may be formed all throughout. Kasi remember, gelatin is may still lose its consistency over time, so you can actually monitor it from also. Okay? So ganyan po. Any questions so far, guys, with the activity this coming week? Questions, clarifications, violent reactions so far? Yes, Miss Autumn. Actually, that is a good question. The problem kasi natin is, as much as possible, when we do experiments, you have to make sure that all of the components are controlled. Um, paano nyo masisiguro na lahat kayo pareho yung volume? Not everybody has access to the same measuring devices at home. So the only thing that we can come up that would allow you to have similar components or similar materials would be the taho cup. Okay? Unless that you have any other options na mamimit kayo, kung magkakalapit kayo, and then you'll distribute a few samples, a few pieces of that plastic transparent cup, then that's good for me. Pero if in case you don't have the opportunity to do so, then yan lang po. Okay? Yes, Miss Autumn. Mhm. Puwede namang hugasan. Hmm. Ano na na, sorry, come again? About the gelatin? Ipe-prepare pa siya? Pagkaluto na yan siguro fresh before, pagkaluto niyo yan kumbaga bago kayo mag-start na maglagay ng fruit, so yun yun. So puwedeng kakagaling lang niya sa freezer or sa refrigerator, so solidified yan. So definitely wala ka dapat makikitang watery part yun, kasi fresh pa siya, eh. Kumbaga wala pang other factors that would interact with it. If I think if that's what you wanted to clarify, Miss Otom, is that right? Mhm. Any other question, guys? Yes. Miss Marasigan, good morning. I'm sorry, come again? Sorry, medyo maano yung last part. Ay, hindi po. Hindi po siya kasama sa video shooting. If that's what your word. No, no, it's not. Thank you. Any other questions? Yung video shooting natin would resume when we go to urinalysis. So yung, I think meron tatlo pa lang tayo, di ba? Ng laboratory na may video. Tama ba o apat na? Tatlo pa. So may tatlo pa tayo. So we have still lipids, and then we will start urinalysis and then blood analysis. Sino kaya ang kukuhanan natin ng dugo? Okay? So yan. Meron naman tayo dito guys na licensed medical technologist. Our department head is a licensed medical technologist. So magdadala lang kayo ng ng syringe. Kukuha tayo ng dugo. Unless sa gusto niyo sa daliri natin, tas pitik-pitik-pitik, magaganyan-ganyan tayo hanggang makabuo tayo ng 3 ml. Okay? Kayo. Any other questions so far? Okay. Rika, any question from your side? Andiyan ba si Rika? Okay. No problem. Okay. So for today, let me just start with my PowerPoint. So this will be talking about metabolism and bioenergetics. So this is actually the part na kung saan ano na tayo, mag-invest heavily na tayo sa lectures natin. Okay? So make sure that you understood correctly because all of the information here is hindi na siya katulad nung nating na, 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 naipon ninyo all throughout the first half of the semester na madali-dali pa. Okay? So yeah. Now, wait lang. Let me just pull up my things here. Yeah. Okay. So, so when you say metabolism, this is actually the sum of all chemical transformation that's taking place inside the cell, and it's usually through a series of enzyme catalyzed. Again, take note of the term enzyme catalyzed. Okay, so there is enzyme catalyzed reaction that usually constituent to the metabolic pathway. Okay, now take note that each of the consecutive steps in the pathway brings about a specific small chemical change, usually either by removal, transfer, or addition of particular atom or functional groups. Now, usually we have what we call precursors. When you say precursors, these are materials or compounds that can be converted to form now your metabolic intermediates or what we call the metabolites. Okay? So, kasama na po siya dyan. Okay? So, ito po yun usually makikita niyo mga terms sa pagtatandaan. Precursor. So, for example, like the one that we discussed last time in terms of enzymes. By the way, I already updated the PowerPoint in the TBL Hub for your class. Example ito is Zymogen, 'di ba? We have trypsinogen, pepsinogen. So ang precursor ng pepsin is pepsinogen. Ang precursor ng trypsin is trypsinogen. Yan. So and then the metabolite is the pepsin, the enzymes and or the other substrates that we'll be discussing. Okay? So when you say intermediary metabolism, it's often applied to the combined activities of all the pathways. Okay, usually it can interconvert precursor, metabolites, and other products of low molecular weight. Now, if you're going to talk about metabolism, we have actually two parts. Okay, so the first one is catabolism. So this is the degradation phase of the metabolism. So you break it down, parang rapper, break it down, gagayan kayong bigla. Okay? So yeah, so you actually break down your materials into the small components. For example, sino dito sa inyo ang nagbe-breakfast currently? Huwag na mahiya. I know some of you are taking their still having their breakfast at this time. Well taken yan. Rainier, Mr. Burse, what are you having today? Itlog at saka hotdog. Walang rice? Nagno-no carbs ka? Oh, ang sarap-sarap naman yan. Sana all. How about Miss Cossicol? What are you having today? Wow, white rice and scramble. Okay, see, Brent, nagre-raise ng hand kanina. I saw Brent raising his hand. Would you like to say share? Wala na si Brent. Oatmeal, si Sir John. Wow, ikaw na. Siomai rice. Parang dito lang yan sa canteen, no? Siomai rice. Okay, so yan. Okay. Tusino, wow, tamis na umaga ni Mr. Tingedan. Okay, so yan. So, pag-usapan natin yung breakfast ni Mr. Tingedan. So, that is actually tocino, right? So, it's usually tocino rice with fried rice. Tas kape na. Ay. Kaya hindi tayo payat eh. Lumalaki. Ang sarap ng mga foods natin. Lalo na hindi masyado nagbe-burn out. Okay, so the food that we actually eat, so if you're gonna classify that, you have the protein from the meat, then you have sugar, it's still gonna be counted as a carbohydrate. Then the rice, okay, carbohydrates yan. Okay, tapos alam niyo yung sumasarap sa tocino, yung medyo mataba-taba, di ba? Charap, 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 charap nun. Sorry naman, Norjana, hindi ka ano dito. Anyways, basta yun. Okay, now, so this is actually going to convert it to smaller components. So remember when we discussed carbohydrates, going to be broken down to your sugar compounds like your glucose and other smaller molecules. Then for proteins, it's going to be broken down to amino acids. And then later on, it will be forming now the other materials that will be used. So, pwede siya maging ATP, pwede siya maging carbohydrates, and whatever that's needed by the body. Okay? Then the other one is anabolism. It's also known as the biosynthesis. So, ito naman yung kabaligtaran. So, the ones that we have broken down earlier is going to be building up the needed molecules for our body's regular functions. Okay? So example of that one is ATP, NADH, NADPH, and FADH2. Okay, so that's in anabolism. Okay? So if you're going to combine all the two together, so this is the overall metabolic process natin. So as you can see here, brewed coffee, nasa harapan ko brewed coffee naman. Okay, so it actually allows, given these two reaction, it allows us to utilize and synthesize the different biomolecules that will be needed for the body's function. Okay, now, ayan na ang malaking mapa. This is actually uh, the reactions, okay, where the catabolism and the anabolism is happening. So this, if we divide it with colors, you will see that this one is catabolism. Okay, so this is actually um, starch, glycogen, sucrose. This is sugar, carbohydrate metabolism, protein, lipid metabolism broken down. Then you have the Krebs cycle, the cyclic pathway. And then it will now, bango ng kape. It will now become your anabolic pathway. Okay, so here is combination to form your different materials. Okay, yeah. Now, if you're going to analyze the pathway itself or the whole metabolism per se, ito yung mismong specific parts nun. So the first one is usually mainly hydrolysis. So you're actually going to be adding water molecules into the components and break it down to the smaller components. And then the second part of the metabolism is actually the conversion of the units that you have there. You have your amino acids, the mono and di, and the fatty acids to form now your pyruvate or your acetyl coenzyme A. And the last one is the oxidation. So in here you have your TCA cycle, the this is the electron transport chain. Yan. And then you also have here yung production natin ng urea, the urea cycle as well. Okay, so this is the last part of our metabolic cycle. Now, things to remember about metabolism. Always remember that anabolic and catabolic pathway are reciprocally regulated. Okay? So, yeah. Okay. Next one is, yan. So, example of this one is fatty acid synthesis. Ayan, are not bone turn on simultaneously. So, kung ano yung kailangan, siya yung mag-activate or mas mabilis ang process. Remember, we do not shut down the metabolism. We just speed it up or slow it down further. Okay? Wait lang. Yan. Next one, catabolic and anabolic pathway that connect the same 2 points may use many of the endpoints, but at least one step is catalyzed by different enzyme. So an example of this one is gluconeogenesis. Okay, so actually this is two pathways, the gluconeogenesis and the glycolysis. You might notice that they actually are the same. It just so happened that some of the key points there, actually it's 135 if I'm not mistaken, or 137, wherein it is going to be regulated. Okay? So, and at the same time, at that particular regulation points, iba rin yung enzyme niya. Okay? And paired metabolic and catabolic anabolic pathways occurs in different cellular components, which is actually true. Okay. So an example of this one is fatty acid synthesis. Guys, this is already a keynote. So remember that fatty acid synthesis occurs in cytosol, while Fatty acid degradation is in the mitochondria. Now, the reason why I'm asking you to look into this one already because I will be including that also in our quiz. Okay? Kumbaga, yan yung mga importante na tinatana and most of the time guys kasama rin yan sa mga higher subject ninyo din. Okay? Yan. Kumbaga ito guys, although nalulula na kayo siguro, yeah, oh, ito na. This is it. This is the major part na. Wala pa yan pagdating niyo sa mga major ninyo pagdating ng panahon. Okay? So yan. Okay. Now, bioenergetics is a branch of biochemistry that focuses on how cells transform energy, often from producing and storing or consuming adenosine triphosphate. Okay? Now, it concerns energy involved in making and breaking of chemical bonds in the molecules found in biological organisms. Now, the role of energy is fundamental to biological process like growth, development, and metabolism. Cellular process like cell respiration, metabolic and enzymatic process lead to the production and utilization of energy in the form of ATP. So yeah, narinig yun na naman na ATP. This is also known as the energy currency of the cell. Now, the ability to harness energy from the variety of metabolic pathway is a property of all living organisms. Now, so ito na. What is gives free energy? So this is the energy associated with chemical reaction that can be used to do work. Naalala nyo when we discuss about enzyme, yung delta G, na nilagay ko doon sa may diagram, yan na po yun. That's gives energy, free energy. Now, the free energy of a system is the sum of the enthalpy. Ala, nag-enthalpy si ma'am. And the product of the temperature and the entropy of the system. Now, I'm not gonna go heavy for you guys kasi ito physical chemistry na to eh. Um, Physical chemistry, parang physics ng chemistry. Yan. Okay, so this is actually based on the formula delta G is equal to delta H minus T times delta S. Okay, ano ba yung mga yan? Okay, so delta G is the free energy change of a reaction. Okay, so usually it tells you if it is an energy reaction that is releasing energy or if it is absorbing energy. So if it is releasing energy, it's called as an exergonic. And if it is positive, it means it is gaining. It is endergonic. Okay. Now, delta H is enthalpy. So this is the change. It is amount of heat. Okay. This is the change in enthalpy from the conversion of reactants to the product. So if delta H is negative, okay, it means it releases heat and it is exothermic. Now if it is positive, it is absorbing heat and it is called as an endothermic. Okay, so take note of the terms. Endothermic, nag-absorb ng init. Exothermic, nag-exude. Kaya nga di ba may term tayong exude. It means exo, outside. Hindi exo fans ha, hindi po yon. Wala muna tayong exo muna ngayon. Okay, again, endergonic, it is, uh, it is actually gaining. And then exergonic, it is releasing energy. Okay, next, entropy disorder. So this is actually guys, when there is a reaction, it does not normally say na kailangan nakapila yung bawat components ng ano natin para mag-react sila. No, it's not the case. It's usually free and it's chaos. Okay? The more chaotic it is, the higher the possibility that they will have a reaction. So, so if the products of the reaction are more disordered, it will have a higher or a positive value. Okay? Kasi maraming nagiging reaction. Kumbaga, ano eh, mas mataas ang chance na makabuo kayo. Ika nga nila. Okay? Okay. So here, take note of the unit. So if it's delta G, delta H, it is joules per mole. Pwedeng calories per mole. Okay, so sinulat ko lang dito yung mismong value. So 1 calorie is equal to 4.9194 joules. And for entropy, it's joules per mole times Kelvin. Okay, or J per mole K. Yan. Now, laws of thermodynamics applying to living organism. Now, bakit sinama ko to sa inyo? Kasi if you're not able to apply this, we will not be able to understand why we are having such kind of reactions in our body as well. Okay? Bakit kailangan maraming sperm para sa isang egg cell lang, 'di ba? May mga ganung mga tanong. Okay, wait lang guys. Okay, wait lang guys ha. Merong gusto mag-project sa laptop ko na hindi ko siya kilala. Binlock ko lang. Okay. So yan. Okay, number one. Organisms cannot create energy from nothing. Of course, guys. Ano yan? Poof! Isang pitik lang. Isang ganun lang. Magic! No, it cannot. So, ganun din. Di ba, remember, if we're going to talk about energy and matter, di ba, energy is neither created nor destroyed. So, ganun din pagdating sa living organism. Okay? So, it cannot create, it cannot destroy. It usually it changes from one form to another. Okay? Parang pag na deads ang isang organism, it does not go, nag-ano na kagad siya, nag-disappear. Okay? Parang pag nanonood tayo ng mga K-drama tsaka mga ano, hindi po gano'n. It usually changes into something else. Okay? It's gonna be a dead body, then later on, it's gonna be uh, disintegrated in the process, di ba? Yan. Now, in the process of transferring energy, living organisms must increase the entropy of the universe. Okay? Ano daw yun? Masyadong mga highfalutin yan. And then, in order to maintain organization within themselves, living system must be able to extract usable energy from the surrounding, release useless energy back into the surrounding. Okay? So, yeah. So, this one, okay. Ito yung sinasabi ko sa inyo, uh, there should be for the process of transforming energy, you have to increase the entropy of the universe. So, and then the other one, for the second one, ito yung nangyayari naman natin ngayon, di ba? If in case we work on something, ano nangyayari sa atin? We tend to perspire, we tend to heat out. So we tend to bring the energy, the heat back into the surrounding. So physics, guys, heat is a form of energy. Okay? So yeah. Now, based on the thermodynamics applied on living organism, the first three is actually, if you will notice, it's color coded. So the first three are red. So this is catabolic. Okay? And this one is anabolic in nature. Now, questions, guys. Questions, clarifications, violent reactions, Rika. Kaya pa? Don't worry, I have recorded this as well, so I'll upload it later on if in case you're having problems with your connections. Wait lang ha, higup lang ako. Ano yan? I'm drinking, ano yun, kunyari Starbucks, lemonade coffee. Yan, kakaiba. Okay, so yan. So let us actually review our knowledge on free energy and equilibrium in order for us to understand this further. So as mentioned, in order for to drive chemical reactions, Cells need sources of free energy. Okay? Now, free energy can be gained, okay? Can be gained from non-equilibrium systems moving toward equilibrium. Okay? So, ibig sabihin, hindi pa balance going to an equilibrium state. Okay? So, now free energy is usually governed by the equilibrium constant KEQ. Okay, so that's equilibrium constant. That's the label for that one. Okay. Now, for teka lang, wait lang, Fee. Now, for the equilibrium reaction, it's A sub A plus B sub B, B of B, reversible reaction of C plus D of D. Okay, so this one, if you're gonna look at here, so A, small letter A stands for coefficient. Coefficient of A, and A is the compound. B, small letter B is coefficient. When I say coefficient, this is a number that represents the number of molecules or atoms that are inside the reaction. Okay, so that's C, coefficient of C, and coefficient of D and D. Now, with this reaction, we usually form an equilibrium constant KEQ. Now, your KEQ are usually formed from the product of the products, okay, raised to their respective coefficient divided by the product of the reactants the concentration of the products raised to their respective coefficient divided by the concentration of the reactants raised to their respective coefficient. Kaya C raised to the coefficient of C, concentration of D raised to the coefficient of D, coefficient of A raised to the uh, product of concentration of A rather raised to the coefficient of A, and then coefficient product of B raised to the coefficient of B. Okay. Now, and the standard free energy change is given by the minus RT, okay, in the product concentration of C to the power of C times the concentration data that of poverty divided to the concentration of A to the power of A times the concentration of B to the power of B. The standard free energy change from the chemical reaction is thus simply the alternative mathematical way of expressing equilibrium constant. So, yan po. Okay? Since KEQ to eh. Okay? Remember, KEQ yan, ito yung mismong formula. Ito na ngayon yung combination ng equation nila. Okay? Now, here, is a relationship between the equilibrium constant and standard free energy changes of chemical reaction. So here, if you will look into this one, so this is our equilibrium constant. So pag 10 to the 3, that's 1,000. That's negative 17.1 kilojoules per mole free energy, or 4.1, negative 4.1 kilocalories per mole. And as you notice here, as you go down, or you notice here, habang bumababa yung value ng equilibrium constant natin, what happens to the change, the delta G natin, yung Gibbs free energy natin, tumataas din siya. Okay? Almost 10 times ang tinataas niya, times 10. Okay? So that's the relationship between free energy and the standard free energy changes of chemical reaction. Okay. Now, here is just a table showing the relationship further if you're not just going to go to the values. Now, if your equilibrium constant is greater than 1, therefore, the delta G or yung gives free energy natin is negative. Therefore, it proceeds forward. Pag proceeds forward yan guys, it is favoring products production or products, okay, formation. While if it is equal to 1, there is no movement. So ano na, equilibrium na tayo. Kumbaga, yung pendulum nasa gitna na nakarest na siya. But if it is less than 1, delta G now or your free energy is now positive. Therefore, we are favoring the production of the reactants. Okay? So backward reaction tayo. Kaya nga proceeds in reverse. Okay? So here in this table, you will notice these different hydrolysis reactions. So if you're going to look into the different hydrolysis, you have acid anhydrides, esters, amides, and peptides. You will see their free energy, standard free energy changes. Okay? So yung mga ito, maliliit lang siya, lalo na yung sa mga malate and the others here. But if you're going to oxidation, ayan, thousands ang pinag-uusapan natin. Okay? So, yan po yung inyong ating how big yung mismong amount of energy that is released from oxidation. Kung hydrolysis lang, breaking, hiwalay-hiwalay, carry lang. Maliliit lang. Okay? Yung oxidation ang malakas humatak ng energy. Kaya makapag-produce. Now, how about inside the cell? Okay. So, usually, the criteria for the reaction spontaneity is delta G not gives free energy. Okay. Yung ito po is delta G. Ito, delta G. Ito yung gives free energy. Now, consider the following interconvection. X and Y. So, if equilibrium constant K, X to Y is less than 1, therefore, your delta G is greater than 0. Now, what would the ratio of X is to Y would look like at equilibrium? So, it means that there would be reaction if headed if the concentration of X is equal to 0 and Y is equal to 1. Okay? So, sequestering products can drive unfavorable reaction forward. Kumbaga pipilitin nyo yun, lalo na kung hindi sila equilibrium. So what will happen is that if Z is very favorable, Y will be more ready to occur. So this is your reactants. These are actually three-step reactions. Okay? X is to goes to Y becomes Z in the process. Yan po yung ibig sabihin nito. Now, ayan yan, no. Napunta dito yung X. Ba't ganun? Kasi kinonvert ko siya guys. Wait lang ha. Nawala yung pwesto ng aking mga symbols ba? Wait lang guys. Sometimes understands what sound is the mind. Nawala sa pwesto. Anyway, yan. Okay? Okay, the actual free energy changes depend on the reactant and product concentration. Ito isa sa mga mabibigat ito. Remember when we discussed enzymes and substrate, concentration of the enzyme, concentration of the substrate, it will definitely have an effect. Yes, Reina. Ay, sorry naman. Nag-enjoy ako mag-off mic. Ano ba yan? Sabi ko sa inyo eh. Wag naman. Gusto kong, although masarap magpahinga na over the weekend, kaya lang, kailangan mag-work. Teka lang, wait lang, inom ulit ako. Kailangan magising ang di ko, hindi. Hindi guys, uminom kasi ako ng gamot para akong lasing sa pinabawal na gamot. Pinabawal na ano 'to, propanolamine. Naku, pada-drawing ko sa inyo yon. Okay. So here, so 'di ba remember this is our formula, okay? So yan yung formula natin and if you're going to write it, the concentration of C i-re-ratio siya dun sa coefficient niya. Kaya concentration of C raised to C, concentration of D raised to D, all over the concentration of the reactants raised to its respective coefficients. Okay? So this is actually equal to the mass action ratio, which is represented by Q. So if the actual free energy change, okay, that delta G is equal to the free energy formula, um, gives free energy plus RT, the limit of K equivalent now is equal to free energy plus RT ILN. Okay, so this is now represented by the mass action ratio rather. Kaya ito po yung formula. This is the one that I also showed earlier. Now, initially, reaction proceeding towards equilibrium is delta G is equal to negative. The negative of delta G becomes less and more less eventually zero when equilibrium is reached. Okay? So, yan. Kumbaga, paliit siya na mabaliit kasi nga, yung reaction niya, pababa rin ng pababa. Parang pendulum. Okay? And later on, titigil na siya. Kaya nagiging zero na yung delta G ninyo. So, if it is zero, okay, so you have your free energy plus RT, L, and Q. Therefore, at equilibrium, okay, so concentration na siya, wala na siyang coefficient kasi nga wala na pong coefficient dyan. Then this will become free energy plus RT, L, and K equivalence. K equilibrium. Okay? K prime equilibrium. Okay? Now, standard free energy changes are usually additive. Now, when you say additive, it actually forms up, or builds up rather. So here, in reactions A to B, this is reversible. So for it to form B and B to be forming A, you need to have free energy. Okay? And for B to form C, you still need delta G. Now, it's not the same. Kaya nga naka-label siya as 1 and 2. Okay? So to summarize yan, um, to change from substrate or compounds A to C, the sum of your free energy is equal to the free energy 1 and free energy 2. Kaya nga additive siya. Okay? So for example, glucose plus pyrophosphate. This is pyrophosphate will become glucose phosphate plus water. Now, in order for that to happen, you need to have also another chemical or another reaction that would simultaneously work at the same time. ATP plus water would give you ADP plus pyrophosphate. So if you're going to sum it up together, what will happen is, wait lang, kunin ko ang aking mahiwagang Volfan. Wait lang. Ayan. Okay. So usually this is a this is your reactions. We're gonna add all, excuse me, the reactions in here. So remember you have, ano ba yung mga common ninyo dito? So you have pyrophosphate here. Teka lang. I think it's, ayan. Yan. So here, remember you, ano ba yung mga pareho mo? Okay. For the reaction, glucose pyrophosphate to glucose 6-phosphate plus water, your delta G is 13.8 kilojoules per mole. And then the other one, yung ATP plus water with plus forming ADP plus pyrophosphate, it is negative 30.5 kilojoules. Okay? Now, to form this one, parang nagmamat din kayo. So, you just remove the common. Kung meron sa reactant sa products, tanggalin nyo yun. So, yung na matitira na lang is ATP plus glucose, ADP plus glucose 6-phosphate. Kaya ito na po yung final. So, ganun doon. Pag-add nyo itong dalawa. So, you'll get the answer. Negative 16.7 kilojoules per mole. Okay? So, yan po yung sa characteristics ng standard free energy. Okay? So, yan po. Any questions so far, guys? Yun na kaagad yun, ma'am. Discard natin. Okay? Questions, clarifications, violent reactions. Okay, bioenergetics pa lang yun, guys. Okay, so that's for bioenergetics. Sure wala kayong question? Brent. Rika. Okay. Teka. Although maaga pa. Ma'am, 9 o'clock lang. Meron pa tayong, we still have plenty of time to work on this. Wait lang, guys. Let me just pull up yung isa PowerPoint ko. Carbon. Opo. Hmm? Ano ba pangalan ng file ko dito? Wait lang, guys. Hi, guys! Malapit na magpasko. Are you excited? Uy, hindi ba kayo na-excite, guys? Hmm? Wait lang, guys. Wait lang. Okay. The calm before the storm. Ano ka, buddy ka? The calm before the storm. Lapit ng Pasko. Ilan ba 'tong PowerPoint? 41. Okay, kaya 'to guys. Kayo pa. Kayo pa. Kaya niyo 'to. Okay. So let's talk about carbohydrates. Metabolism. Okay. So ito yan. Ayan. Okay. So this time we're gonna be talking about carbohydrate metabolism. Now, what you have in front of you is our ATP. Say hello guys to ATP. It's actually short for deoxy ATP or deoxyadenosine triphosphate. So it's actually made of three parts of our biomolecules. You have a phosphate group, an adenine, and the deoxyribose sugar. Okay. Now, if you're going to compare your ATP with the other phosphate containing compounds, you will notice that some of it, for example, glucose 6 phosphate is around negative 20, while glycerol 3 phosphate is around 15, negative 15. Okay? Then you have also creatine. You have 1,3 biphosphoglycerate and phosphoenol pyruvate, di ba? So if we're talking about energy releasing, why not choose any of the others? Well, for example, bakit di ka na lang mag-phosphoenol pyruvate, right? However, the problem with this other metabolites that we have here is that they are actually forming part of our metabolism cycles, okay, metabolic cycles. While ATP, although negative 30 lang siya, wala siya ibang gagawin kundi maging energy currency. Kumbaga wala siya masyadong ibang trabaho, wala siyang ibang gagawin kung hindi mag-work lang during the metabolism para mag-facilitate ng phosphate reactions. Okay? So wala siya ibang gagawin. So yun lang, yun lang, yun lang. Okay? While the rest are part of our metabolites. Okay? Kaya yun. Kaya siya lang. Now, the first reaction is called glycolysis. Yan na tayo. Magpa-pathway na tayo, guys. Kapit lang. Kaya yan. Kaya yan. Kanina calm before the storm. Medyo nalulula pa kayo sa rami ng terms. Ito na talaga. Unang hagupit. Papasok pa lang ang storm. Yan. Glycolysis is also known as Emden-Meyerhof pathway. Okay? Now, to give you a background on this one, nagkataon lang na pareho sila nung dinidiscuss, but they did not work directly together. Okay? So, kaya binigyan sila ng pareho. Now, yung kay Emden, meron siyang ibang mga, to give you a big background of the glycolysis, si Emden meron pa siyang mga collaboration with other scientists. However, sa kanilang sa kanilang dalawa lang ni-name 'yon, okay? So yeah. Now, the pathway of glycolysis is actually yun yung main function niya, to convert glucose into pyruvic acid. Okay? Yun lang. Now, the energy release from glycolysis is going to form high energy, will form ATP and reduce nicotinamide adenine dinucleotide or NADH. Yan guys, tandaan nyo na yung mga terms. Yan, tandaan nyo to. NADH is nicotinamide adenine dinucleotide. Yan. Then, metabolic pathway does not require oxygen. This is anaerobic. Okay? The wide occurrence of glycolysis in other species indicate that it's an ancient metabolic pathway. Okay? Um, bakit naging ancient metabolic pathway? It was believed that before, when the earth was evolving or changing, until millions of years ago, wala pang oxygen. Later na lang nakapag-evolve, nakapag-produce ng oxygen. Okay? So all of the materials back then were not used to oxygen. That's why we have the anaerobic reaction. Okay? Late na yung oxygen formation. Now, in most organisms, glycolysis occurs in the liquid part of the cell, also known as a cytosol. And the most common, ito yung sinasabi ko sa inyo, yung iba't ibang version ng glycolysis. You have the Enden-Meyerhof-Parnas. Okay? So, ito yung mga yon. Idagdag niyo si Jakub Karol Parnas. So, again, mga ano to, mga European. Kaya, yung J is ya. Okay? And puwede siya din tawagin na Ednar-Dudoroff pathway, 'yan. Kasi meron pa siyang iba yung mga fermentation pathway na kasama, okay. So 'yan po. Okay, so let's go na plug glycolysis per se. Sabi niyo, "Ma'am, ano 'yan?" Okay. Sino na-shock, taas ang kamay o hinanda niyo na lahat ng mga inyong kalooban sa pagkakataon na 'to. Na-shock ba? May na-shock ba tayo sa dito? Ha? Pray ka? Brent, Sir John, o hinandaan niyo alam niyo na 'to, kumbaga ano na, pray, pray, pray lang. Excuse me. So, medyo totoo 'yan, pray, pray lang. Sabi ko nga sa inyo guys, eh, when I was still studying back then, decades ago, 'yan, 'yun yung mga panahon na 'yan yung mga pinag-aralan namin and we know, I know guys, napakahirap siya. Okay, wait lang. Hala, wait lang guys, wait lang. Wait lang guys. Okay. Sorry. Okay, so here, what you're looking at right now, sinurrender ko na yan. 10 Hail Mary. Grabe ka naman, Rika. Ano no, totoo yan. Okay. So this one, okay, what I'm doing here right now is I divided it in two parts. The first part is actually what we call the preparatory. Good morning. Ay, kunin na lang po sir yung, sandali guys. Susi. Okay. So we have the first half is what we call the preparatory stage. So this is the part wherein we phosphorylate glucose and convert to glyceraldehyde triphosphate. Actually guys, sabi niyo lang, sabi niya, ma'am, from glucose to glyceraldehyde triphosphate. Yun nga lang guys, the actual reaction from glucose to glyceraldehyde would take a couple of steps. Actually, if you're looking at right now, it's 5-step reaction. Okay? And this is also known as the investment stage. Why investment stage? We are producing ATP. If you're going to look at the chart here, you have ATP1, okay? ATP, and okay? So this is the first priming reaction. Big sabihin ng investment, add ka ng phosphate, add phosphate, add phosphate. Okay? So here, the first one is, so isa-isayin natin yan. Then next is, wait lang, mamaya natin isa-send. Yield phase muna. Yield phase or the payoffs phase. Okay, so this is actually the oxidation part. The conversion, oxidative conversion of glyceraldehyde to form our ATP and pyruvate in the process. Okay, so here, it will now be broken down to two, from, di ba kanina glucose to glyceraldehyde. Dalawang glyceraldehyde. Okay, um, this will now produce now your NADH. Yeah, kaya nga yield, produce, or payoff. Kumbaga, nag-invest ka kanina ng dalawang ATP, this time, tutubo na tayo ng NADH at apat na ATP. Okay? Now, take note na kanina, do sa preparatory stage natin ng glycolysis, we actually consume 2 ATP. Okay? So, mamaya we'll do the math. So, let's do, isa-isahin natin yan. Yan. So, yung first one, you have glucose, okay, producing now your glucose 6-phosphate with the enzyme hexokinase. Yeah, take note of the enzyme hexokinase. Now, take note here, I got this in, medyo reliable naman yung source na pinagkuhanan ng source ko. Okay? So, this is an example of a transferase kasi yung phosphate from ATP, remember, I used this an example last time when we discussed enzymes. It added phosphate to your glucose. Okay? So, that's why it's a transferase. Okay? So, take note of the words that we have then. Okay? This reaction consumes ATP but it acts to keep the glucose concentration low. Okay? Kung mataas ang sugar natin, i-shift natin yan to glucose 6-phosphate as an alternative. Otherwise, mahihirapan ang system natin. Okay? So, pass through plasma membrane transporters. Now, in addition, it blocks glucose from leaking out. The cell lack transporters for glucose 6, and free diffusion out of the cell is prevented through the charged nature of G6P. Glucose may alternatively form from phosphopyrolysis or hydrolysis of intracellular starch or glucose. So this is the alternative. Kumaga, if in case wala kayong sugar. Okay? Now the other one, the second step is from glucose 6 to fructose 6 phosphate. Okay? Now your enzyme is phosphoglucoisomerase. So this is an isomerase enzyme. And this is, if you look here, it's reversible. Yung kanina, it's irreversible. Okay? So hindi na siya. Wait lang guys, wait lang. Tikits, sorry, nagturog si ano, si sini last week. Yung kasabayan ko na nag-lab. Oo. Oo. Siya nga yung nagpunta. Hmm? Ha? Sa, sige sir, okay lang. May kape yung ano ko, juice ko. Okay. Ayan, wait lang ha. Okay, so here. So if you recall this one, take note. Ito, irreversible. This is a regulation stage. And this one is reversible. Okay? So, actually rearrange G6P or glucose 6-phosphate to F6P. Okay? So, it can undergo phosphorylation. Okay? This change in structure is an isomerization in which the G6P is converted to F6P. It requires the enzyme phosphoglucoisomerase to proceed, and it is reversible. Now, the third one rather, is uh, from F6P, it becomes F16BP, okay, or fructose 1,6 biphosphate. Now, we use another ATP here, and it's also a transferase. Now, if you will go back, guys, iba yung kanilang enzymes. Sabi niya, "Ma'am, pareho namang phosphate ang i-add natin. Remember, we have different substrate. And different substrate will call for different enzymes." Okay? Kaya, if you apply, ba't naman may ganun sa likod? Ano yun, Rika? I know, right? Actually, last na ano pa, ano dun sa, hi! May nakikita daw sila tiki sa likod. Hindi, yung mga estudyante ko, hindi ganito yan, guys. Di ba naka, ko, naka-AI yung ano ko, naka-background ako. Pero lumalabas yung model sa likod. Oo. Kasi usually naman, ang nakikita niya dapat is nasa harapan, di ba? Pero matagal ko na siyang napansin. So, say hi na lang. Meron talaga dito. Okay? Tapos na ang undas. Pero meron talaga dito. Ilang beses na. Baka nga Rika makita mo yung gwapo. Gwapo yun. Nakita ko. Sobrang gwapo siya. Kaya lang deads na siya. Okay? Hindi yung biro guys. Nakita namin talaga. Kumaway pa sa harapan ko noong time na yon. Talagang naloka ako nun. Anyways, may anong love no? So, baliw, Nika, hindi maganda yon. Mahirap yon. As in, ano siya, oppa talaga siya. Isang siyang oppa. Kaya lang meron din, baka yung nakikita mo yung babae, hindi lang isang beses, yung babae lagi nakikita dito. Yung bigla na lang, ring na gumaganon siya. Yan. Anyways. Okay, going back to this one. Rika kasi. Hindi, ano ba kayo? Actually, mabait naman sila. Kaya minsan nga pag sabihin ko, kain tayo. Pag gumanon ako, ibig sabihin may dumaan na nagpaparamdam. Although science ako guys, pero I have also some experiences kasi. Nag-alok ka na ba tikit sa mga tao? Kain tayo, yan. Anyways, yan, yan. So here, this is actually the third reaction as I mentioned. Okay? Pero sa gilid ba? Oo, may sumisilid sa gilid na natuwa kasi siya na cam ako last time. Tapos every time tuloy nagka-cam ako, ayan na, meron na siya. Anyways, yan. So going back to this one. So yan. So this is again a regulation point. Again, why regulation? It's irreversible. So this is the addition of phosphate group here. Okay. So take note that you also have magnesium ions as a cofactor for your enzyme. So the glycolytic process is irreversible and the energy supply destabilizes the molecule. Because the reaction is catalyzed by phosphofructokinase or PFK1, it's coupled by hydrolysis of ATP. It's irreversible and a different pathway must be used to do the reversible conversion. Okay. Now there is gluconeogenesis, as I mentioned earlier in the previous topic, is the reverse. As in talagang reverse siya. Okay. However, you're not gonna be using the same enzyme, ibang enzyme ang gagamitin nyo. Now, it's also rate limiting, guys. Ibig sabihin, it's gonna be impacted also para siyang some sort of a feedback inhibition. Um, Pag masyado mababa yung mismong supply ng fructose 6-phosphate or yung mismong pyruvate at the end of the session or the end of the reaction, bibilisan 'to. That's why it means rate limiting step. If in case mataas si pyruvate, okay, slow down etong part na 'to. Okay? So that's the second regulation point kasi. Okay? So this is number 4. So here you have your F16BP or fructose 1,6 biphosphate. Hahatiin na natin siya. Check! Yan. Tama ba hati ko? Parang tama naman. Okay? So, hinati natin siya using the enzyme phosphobiphosphate aldolase or or also known as aldolase siya. Pero yung full name niya, ito yon. Okay? Pero pwede siyang nickname, parang pet name, aldolase. So, this is a lyase. So, it's actually cutting it down into three. So, normally, pag hinati mo siya, based on the structure that we have here, one of your product is GADP or glyceraldehyde 3-phosphate and the other one is dihydroxyacetone or DAP. Okay, so again, take note, it's reversible, whichever is needed. Now, for this one, since magkaiba sila, you have to convert now DHP. Gagawin mo siyang GAD. So if you recall here, you have now DAP. Ito yung pagko-convert niya. So DAP using a triose phosphate isomerase or TPI. Again, it's reversible. It's now converted to GADP. So mapapansin nyo dyan sa ibang mga cycles na makikita ninyo is that the sometimes hindi na sinasama yung DAP. Diretso na siya sa GADP. Okay? Glyceraldehyde kagad siya. Okay? Pero we need to show everything to you guys. Okay? Then afterwards, this is now times 2. So dalawang units na lagi ito. So this 2 GADP will now be adding another phosphate, but it's gonna be coming from pyrophosphate. And the enzyme is glyceraldehyde phosphate dehydrogenase, which is an oxidoreductase. You uh, reduce, okay, your pyrophosphate and tama ba? We oxidize it and then reduce. Okay, so here your sugar is oxidized, okay, to form your 1,3-biphosphoglycerate while the NAD is reduced, okay, to NADH plus H for the formation. Okay. Next one is you're going to remove one of the phosphates. So this is the first time we're going to be producing ATP. So yung isang phosphate mo, particularly yung phosphate number 1, yung nasa taas. So tatanggalin na natin siya. Okay? So enzyme natin is phosphoglycerate kinase. So we're transferring a phosphate group from the molecule by phosphoglycerate to ADP, making it as an ATP. Okay? Yan. So this is an enzymatic transfer of phosphate from 1,3 BPG to ADP, making it ATP, and then reducing it to 3-phosphoglycerate. Okay? So this is again still a reversible. Okay? Yan. Then, this time, we're going to mutate it using phosphoglycerate mutase. We're going to move the phosphate from carbon number 3, moving it to carbon number 2. Okay? So we're actually mutating the structure. And then we're going to form now an enol group. Okay? So you're going to have from phosphoglycerate to phosphoenol pyruvate. Okay? So your enolase actually converts to phosphoglycerate to phosphoenol pyruvate. So using again magnesium ions, one conformational ion. Bakit Okay. Sorry, may pumindot. With the carboxylate group of the substrate and one catalytic ion that participates in the dehydration. Okay. So we remove water molecule from this one. We produce water in the process. Then, ito na. Last step. Phosphoenol pyruvate is now reduced by taking off the phosphate group, transfer the phosphate from phosphoenol pyruvate to ADP, producing the second. Okay? Now, remember, this is the second, hindi pangalawa, hindi dalawa. Second ATP na pinroduce natin. Remember, this is 2. Okay? So, lahat ng gagawin na natin dito times 2. So, kung dalawa to, then dalawa to. Okay? So, all in all, you get 4 ATP products. Okay? Yeah. Now, this is the regulation point. Okay? So, again, take note, regulation steps are the irreversible. So, that's 1, 3, and 5. Sorry, not 5, but 10. Okay? So, 10. So, those are the regulation points. Now, yan. Remember when we talk about products, we have what we call the gross product. This is the overall. Then we have the net. Ano yung net? Pag sinabi mong net, guys, isasama mo na kung ano yung expenses. Di ba? Parang net income. Pag sinabing gross, lahat yan. Wala pa expenses yon. Output mo. So here, the gross output of a glycolysis is 4 ATP, 2 NADH, 2 pyruvate molecules. Now, for the net, since yung gumamit tayo ng ATP in the first half, therefore, ang net product mo is 2 ATP, 2 NADH, and then 2 pyruvate. Okay? Pair. Yan. Okay? Questions? Teka lang. So, how do we control it? So, here is actually the things that helps us in regulating your glycolysis. Unang-una is allosteric regulation. We see allosteric regulation, remember when we discussed earlier last week, okay, sa enzyme reaction. So, we actually tend to control the enzyme that helps in that particular pathway. Okay? So, pag mataas ang ATP, yan. Pag mataas, slow. Pag ADP at AMP, you increase. Okay? Ito, slow, increase. Okay? Next, you control hexokinase. So, dito yung first part. Ito yung sa first regulation point. Okay? So, here, ano siya? Siya yung mag inhibit kung bibilisan man natin siya or babagalan. Okay? Kasi, pag mataas ang sugar, increase. Papasukin. Go forward sa hexokinase. Okay? Then, the other one, yung phosphofructokinase, this is the second. So, ito yung sa third step. Okay? So, usually depends on the energy of the cell. Kung mataas ang ATP, again, slow down. Pag mababa, speed up. Okay? And it's also activated by fructose 2,6 biphosphate. Pag masyadong mababa or mataas, yun din yun. Pag mababa yung fructose 2,6 biphosphate, proceed. Pag mataas, slow down. Then, but it can be controlled by another compound, which is citrate. Now, this is actually part of the TCA cycle already. Kumbaga, ibang ibang pathway to, pero it will still trigger the other pathway to proceed or to continue kasi yung ibang component niya pwedeng mag-flow dun sa ibang pathway. That's why it's being controlled by another uh, metabolite. Then you have pyruvate kinase. Ito na yung sa 10th. Okay? So, ATP inhibits pyruvate kinase. So, pag mataas, ganun ulit, slow down. Pag mababa ATP, go, 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 go. Yan. Then, pyruvate kinase is also inhibited by acetyl coenzyme A. This is part of the TCA cycle. Okay? Kasi yung pyruvate, wala silang ibang pupuntahan, kundi TCA cycle lang yan. And then it can be activated by fructose 6 biphosphate. This is feedback inhibition or feed-forward activation. Another term for feedback inhibition, kabaligtaran niya. Kasi pag sinabing feedback inhibition, pag mataas, slow down. Pag itong feedback forward naman siya, ibig sabihin, pag mababa, push. Okay, mababa, push. Pag mataas, slow down. Okay? So, yan yung tatandaan nyo dyan. Okay. Okay, so yan. Any questions so far, guys, with the TCA? Clarification, violent reaction. Ilang slide pa ba tayo? 20 slides to go. Kaya yan, laban, aja! Okay. Next one is fermentation. Okay? So fermentation is a reaction wherein there is no oxidation. So usually reacts with NADH using endogenous and organic electron acceptor. So your pyruvate from glycolysis can enter fermentation. Okay? It can produce NAD ion, organic products like ethanol, lactic acid, and hydrogen gas, and sometimes carbon dioxide. Okay? And it occurs if it's occurring in an aerobic environment, it will be used to generate ATP and it's now called oxidative phosphorylation. Now, yung isang fermentation, we have lactic acid fermentation or lactate fermentation. So here, from the term lactic acid lactate, so this is homolactic fermentation. It's the simplest form of fermentation. So your pyruvate is converted to a glycolysis using just simple redox reaction. Okay? So one molecule of glucose produces two lactic acid kasi from glucose you produce two pyruvate and then one pyruvate is equal to one lactic acid. Okay? So usually it's formed inside the muscle when they need energy. The blood will be supplying this. Okay. Now, if in case for bacteria, you such example is lactobacilli, fungi, they can produce lactic acid. Okay, sa yogurt. Kaya nga, di ba, meron tayong mga yogurt drinks, Yakult, yan. Okay. Now, this type of bacteria usually carry out homolactic fermentation wherein it's usually lactic acid. Kasi meron tayong fermentation wherein it also produce lactate. Kumbaga magto two-step reaction siya from lactate to ethanol. Yan. Okay? So, yan po yung nangyayari doon. So, this is an example of the heteroketolase pathway or yung double or yung tinatawag na heterolactic fermentation. Itong nasa taas, saan na yung mouse ko? Nawala na. Wait lang guys. Yan. Ito yung homolactic. Ito po yung heterolactic fermentation. From glucose to lactate to ethanol and then carbon dioxide. Okay? So, yan po. So, here is the pyruvate to lactic acid fermentation. So, you use the enzyme lactate dehydrogenase. Okay, now, meron din tayong tinatawag na diretso from pyruvate to ethanol or alcohol fermentation. So, usually, this is the reason why we have bread. Okay? Di ba sinasabi ko last time, nilalagyan natin ng yeast, yung tinapay, then after, pagkatapos yung painit-initin, kung saan yung pinapalo-palo ng panadero yon, lalagay sa isang tabi, tapos mapapansin natin, it's gonna rise. Okay? However, hindi lang po sa tinapay meron din. We have also beers. Beer, wine, di ba? Mga nakakalasing na inumin. Yan. Tapos pwede din tayong gumawa ng ethanol for our machineries. Yung biogas na tinatawag, yung merong gasolina hinahalo. Okay? And then, para in some species, they can also produce energy. For example, goldfish and carp. Okay? Usap silang kukulit. Yan. Okay. So here, for ethyl alcohol fermentation, so your molecule is broken down to pyruvate in glycolysis. The energy is exothermic reaction. Okay, so it's when it releases ng energy. and it breaks down into two acetaldehyde compound. Okay, and then your acetaldehyde with the enzyme alcohol dehydrogenase uh, oxidizes NADH to NAD ion to form now your ethyl alcohol. Okay, so yan po. This is just a summary of the word for word description of the reaction per se. Okay, kaya pa ba? Kaya pa guys? Laban pa? Tika, sagot. Kaya pa? Teka, ano ba yung... Ano tinawanan mo lang ako? Sige, i-cut natin. Wait lang ha. Medyo mabigat na yung ano eh. Mayroon pa kasing nauna kayo eh. Wait lang ha. Sige, ganito ang gagawin natin para hindi naman mabigat. Teka lang ha. Kasi sa dalawa. Wait lang. Sige. Hindi, sige, sige. Kasi if you're going to look into our bioenergetics and carbohydrate metabolism, we still have aerobic and then so bioenergetics, metabolism, teka lang, 1, 2, 3. Sige, tapusin natin. Kaya pa yan. Sige, malapit na. Just a few more, 15 na lang. Okay. So, ito yung pentose phosphate pathway. This is actually an alternative pathway for glucose oxidation. So, if in case, instead of going to glycolysis, ito yung pwede na puntahan. So, and it provides energy to the cell in the form of using biosynthesis. Okay? And the byproduct is NADPH. Take note that it occurs inside the cytosol. Okay? So here is the overall product here. So you have glucose 6 phosphate plus 2 NADP plus water, produce ribulose 5 phosphate, NADPH, and then CO2. Okay? Now, what it needs to remember here is that it's these key things, okay? So it actually provides several molecules that are important in biosynthesis. Ano po yung mga molecules? Yung ribulose 5-phosphate, ribose 5-phosphate, cellulose, fructose 6-phosphate, and glycerol 3-phosphate. So if you will notice, guys, instead of going through glycolysis, you'll still be able to produce fructose 6-phosphate and glyceraldehyde 3-phosphate through PPP or pentose phosphate pathway. Now, in some books, it call it as hexose monophosphate pathway. Hala, ano naman yun, ma'am? Hexose monophosphate pathway. That's another alternative for, that's another name for this pathway. Okay? Now, it is important for liver and mammary glands and the cardinal cortex kasi ito yung ginagamit nila. And it produces ribose, which is important for biosynthesis of the nucleotides. Ito yun, oh, yung ribose 5-phosphate. And it's most active in tissues involved in cholesterol and fatty acid biosynthesis. Okay, take note of that important detail. Okay, so here, ito yung buo niya. So you have here your case. Yeah. So you have here your ribulose 5-phosphate. It terms your cellulose 5, ribose 5. Okay, then it can have transketolase. Okay, so you have your glycerol 3 phosphate, your cedulophosphate to fructose 6, also going back to glycolysis, or it can be undergo transaldolase. Okay, so erythrose, fructose 6 phosphate. Okay, so yan yung mga alternative pathways. So this is just showing all the products that can be formed or the intermediates that can be formed from pentose phosphate pathway or PPP. Okay. Now, another one, so ito na yung ating isa, glycolysis, fermentation, that's the second pathway. Third one is PPP or yung pentose phosphate pathway. Pang-apat is gluconeogenesis. Okay? Now, the gluconeogenesis is for the production of glucose, which is the anabolic pathway that is happening inside our liver. So, ito yung reverse ng glycolysis. Take note, yung 1, 2, 3, 1, 3, 10 are using different enzymes kasi. Okay? And then, instead of using ATP, yung source natin ng phosphate group is GTP or guanine triphosphate. Okay? So yeah. So here is actually showing your glycolysis going down, okay? And then your gluconeogenesis going up. Now, ano ba yung steps na yon? So if you will notice the same enzyme here, checkan ko siya. Ito hindi. Kasi ito yung pangatlong reaction. Magkaiba rin yung kanilang enzyme. So this is step 1, step 3 ng glycolysis. Same same. Ito. Okay? Except for this one, this is part 10. Instead of going directly to pyruvate, you actually change from pyruvate. Okay, ito yung pang-sampu eh. Ito yung naiba. Dito lang sila nagkaibang part kasi two steps siya. From pyruvate to oxaloacetate to phosphoenol pyruvate. So, dito sila nagkaibang part. Okay? So, yan po yung tatandaan nyo dyan. Okay? Questions, clarification, guys, before I proceed. Ortiz? Andiyan ka ba, Ortiz? Pakigalaw ang baso. Nan? Okay. Okay, so here, precursors for gluconeogenesis. So, unang-una, glycerol. So, when say precursor, saan pwedeng manggaling yung mga raw materials? So, glycerol, lactate, alpha keto acid. So, when say alpha keto acids, ito yung ginagamit sa protein synthesis. Okay? Then, acetyl coenzyme A and precursors of acetyl coenzyme A, Krebs cycle. Okay? Then regulation of the gluconeogenesis is glucagon. So this actually works as an allosteric effectors. So it inhibits, pag mataas ang ATP, slow. Inhibit ang term, slow yan. Ibig sabihin, slow, dahan-dahan naman. Then ito, speed. Speed, pinadadali. Slow, yan. Then, substrate availability. Again, depende kung ano meron ka. Kung mataas ang pyruvate mo, pag pyruvate, speed up. Pag glucose, slow down. Okay? Kasi nga product niya is glucose eh. Ay, sorry. Yeah, glucose. Then, allosteric activation of acetyl coenzyme A. Now, acetyl coenzyme A is from the Krebs cycle. So, what happened here is that, di ba, ang raw material niya is pyruvate. Eh, kailangan ni pyruvate sa Krebs cycle. So, kung baba si, um, pag mataas si Krebs si pyruvate, pwede siya magpunta doon, 'di ba? Magba-backward siya, pero hinihilad, pwede siyang hilahin ng Krebs cycle in the process. And then here are also the other materials that can stimulate it. Pag mataas yung AMP, ADP, and pyrophosphate, it is PI, pyrophosphate. Okay? It is going to go forward. Okay? Yan. Okay, the last one, last na to. Glycogen synthesis and degradation. Okay? Now, for glycogen synthesis, so we already discussed that. So, sa glycogen, you have your branching and unbranching enzyme. So, take note of the bond here. It's alpha 1 4, alpha 1 4. And for branching, it's alpha 1 6. Okay? Okay, so ito yung straight. Straight. Ito, branch. Okay. Yan. So take note of those branch type of bonds that are present from them kasi that's where the attack is going to happen. So the first one is degradation of glycogen or also known as glycogenolysis. Now here, there are actually a lot of parts from the glycogen where it can happen. So usually on the straight chain. Okay, yung lahat ng 1,4. For the 1,4, wait lang guys. Okay, lahat ng straight chain, it's actually going to be an enzyme of glycogen phosphorylase. So it's gonna receiving phosphate from phosphoric acid, okay, HPO4. So your product is going to be glucose 1 phosphate. So if it is straight, so if it's straight, okay, it's actually glycogen. Pwedeng ang term niyan is, wait lang, itabi ko to. Yan. So it's phosphoglucomutase. Ay, no. Phosphoglucomutase is dito yan eh. So ito lang. So it's straight chain, it's glycogen phosphorylase. Okay? Now, the second one is you have to remove the bond here, yung alpha 1 6. Okay? For the alpha 1 6, you're going to use a debranching enzyme, also known as alpha 1 6 glycosidase. So take note, alpha 1 6 glycosidase. Okay? Now, take note, so this is the branching. Okay, so once na natanggal yan dyan, you just have one free glucose. Wala pong phosphate na nakakabit dyan. Okay, so this is free glucose. Now, once you have free glucose, it can go directly to glycolysis or diretso sa bloodstream as needed by the body. Okay, so yan po yung sa glycogen degradation. Okay, so yung straight chain, pag then afterwards, so natanggal na yung branch, no, pasok ulit si glycogen phosphorylase, yung pagdadagdag ng pagiging glucose 1 phosphate niya. Okay? Kasi po, by the way, I forgot to mention here, what will happen is that from glucose 1, it will be changing to glucose 6 para makapasok siya. From G1P to G6P. Okay? Yan. Then the other one is glycogenesis or also known as glycogen synthesis. Now, your glycogen synthesis for it to work, it has to have a back a carrier material, which is UDP glucose. Okay, so you have UDP, which is uridine diphosphate. So ito yung magdadala ng glucose towards the growing glycogen molecule. So yeah, so here if you will notice you have UDP glucose and this is your glycogen residue or glycogen primer. So pwede siyang ano, pahaba siya ng pahaba. Okay? So parang trend, may lalapit si UDP, kabit. Iwan, alis na si UDP. Okay, so if you will notice here, yan, si UDP nakaalis na siya dyan. Now, once it has already its in number of chains, satisfied na yung number of chains niya, magbe-break siya, magkakaroon siya ng branch. Okay? So, the enzyme that actually forms the branch is what we call the amylo alpha 1416 transglycosylase or also known as the branching enzyme. Okay, so ito yung buong pangalan ni branching enzyme. So, ita-transfer niya yung bond from a 1,4, ilalagay niya sa 1,6. Ilalagay niya sa taas. Okay, causing it to become a branch. Okay? So, yan. Sorry, ito pala yung nickname niya. Glycosyl alpha 46 transferase. Ito yon. Okay, ito po yung, sorry, branching enzyme, ito po yung maliit niyang word. Glycosyl alpha 46 transferase. Now, once nakapag-form na siya ng branch, ganun ulit. Pahaba-haba using UDP glucose. And then, pag nakuha na niya yung number, usually around 20 units, ano, 8 to 10 units, 8 to 12. Di ba iba kasi bawat libro eh. Pero let's say, ilagay na lang natin around 10 to 15. So once na naka-15 na siya, magba-branch ulit siya. That's why glycogen is highly branched compared with starch. Okay? So yan po yung nangyayari sa glycogen formation. Okay? So yan. Any questions so far, guys? Questions, clarifications, violent reactions. Okay. So if you do not have any questions, I'll open bioenergetics and then I'll also open metabolism quiz for this week. Alam ma'am, dalawa. Pwede naman natin extend yung oras. Okay? Madali naman pa tayong kausap if you need more time to work on it. Okay? Any question, guys? Siguradong walang questions. Yes, Nicole. Go. Question, girl. Mm. Ano, um, magsasubmit lang kayo or perform. Papasa. Oh, oh, nakita niyo yung aling wala sa kanila kung bakit mababa yung score nila, no? I know, right? Sabi niyo, oh, sabi, ganda daw kasi, ano ba yung hinahanap ko kasi noon, di ba? Napansin niyo, if you did not place or did not attempted to make a guess, lalo na sa grupo niyo kasi 'di ba yun yung nagalaw yung ano niyo, 'di ba? Hindi na yung iba sa inyo hindi na nag-attempt na baguhin yung or hulaan. Okay, kahit sabihin niyo hindi niyo hulaan guys, makikita ko naman yun eh kung ano yung values ng ano ninyo eh, ng RF ninyo eh. Okay? So usually the nearest answer. Okay? Kaya tinitingnan ko yung mga results. Sige, you can ano naman eh open pa naman, 'di ba? O sarado na ba? O yun, sige lang. So, excuse me. So, kung open, go. Okay? No problem with me. Ah, Na-excite na naman ang group 1? Bro ka talaga kahit kailan, keme ka. Hindi, no, no, no. No need, girl. Ano, diabetic ako, bawal masyadong matatamis. Unsweetened, ma'am, hindi puwede rin, ayoko rin. Tama na ang ano, bitterness sa katawan ko, charot. Any other. Yes, Nicole, go. Yes. If you're going to ask the other groups, they were able to identify the unknown naman. I'm not saying na definite yung RF value, but based, there was even one group na kinuha nila yung ano eh, yung average. I forgot the name. Pero may nakita ko doon, kinuha nila yung average ng whole class. And pinagbasehan nila yon. Okay? Thank you. Kayo ha, mga ano kayo ha. Sige, go. Anything else? Nothing, Oo, 'no, Jana, dapat kasi kaya nga nandodo'n 'yun, eh, 'pag hindi niyo sinama niyo ma-minusan ko pa rin kayo akala niyo, alam ko yung kung ano yung pinagawa niyo, ginawa rin namin 'yan, guys. Sabi niya, "Ma'am, ano pinahirapan kayo dahil sa nangyari." So, no, no, this is still part of your, activity talaga. It's really a must that you'll be able to identify it, okay? Kaya kailangan talaga yung unknown, 'di ba? Kailangan may uncertainty paminsan-minsan, 'di ba? Okay. Double check ko nga 'tong respiration interactive. Dapat talaga oh yeah, I know. I saw that you were able to do that. Balikan ko nga 'to si Bioman kung meron tayong pwedeng magawa dito. Alam ko meron, eh. Pero hindi ko alam kung lahat. Respiration kasi 'to. Mm. Double check ko lang, guys, ha. We still have plenty of time pa naman. Buti magandang ano, internet ngayon, hindi nagloloko. Maaga pa kasi. Parang wala pa. Photosynthesis, respiration. Double check ko lang, guys, kasi alam kong meron tayong activity na pwede dito. Ah, ATP production lang 'to. Hindi, wag na. Last na lang natin 'to. After natin mapag-usapan ang ano, um oxidative phosphorylation and Krebs cycle, which is gonna be next meeting, saka tayo maggaganto. Okay? So yan, kailangan natin to maraming ganto para sa activities natin. Okay? Sige, so just do your activity in the TBL Hub and I'll see you next week. Okay? Sige. Sige. But I'll be available naman on chat on Wednesday if you need clarification on the experiment. So, try nyo na bumili mamaya or meron pa bang taho ngayon? Or mamaya or tomorrow morning nung baso. Kung tignan nyo kung pare-pareho ang sizes, usually pare-pareho lang naman eh. Okay. Yes, I know that, Rojana. Kita ko yung mga sagot niyo and thank you for providing the unknown. Very good. Okay? Sige. I'll see you on Monday. Have a nice week, guys. Bye-bye. Bye. Okay, bye-bye. Bye, Ortiz. Ay. I feel so